Here we'll be solving a radical equation with just one radical. So a radical equation is one that just has a square root in it. We want to first make sure that the square root is the only thing on one side of the equal sign, which it is. Next, we need to undo that square root, and the way that we do that is by its inverse operation of squaring. When we square one side, we do have to square the other, and here's where errors can occur. When you square a square root, they undo each other. So we're only left with x plus 7 on this side. That part's easy. Here's the part where there could be errors. When you're squaring a binomial, like x minus 5, you do have to make sure that you're actually squaring it, which means multiplying it out by itself. So we'll have x squared minus 5x plus 25, which simplifies to x squared minus 10x plus 25. And on this side, we still have the x plus 7. So we can see that we do have a quadratic that needs to be solved. When you have a quadratic, your goal is to get it equal to 0 and keeping the quadratic term positive if possible. So what I'm going to do is make this side 0 by subtracting x and subtracting 7 from both sides. So we'll subtract x and subtract 7. When we do that, we'll have x squared minus 11x plus 18. This is a factorable quadratic, although if it's not factorable, you could use the quadratic formula. And it factors into x minus 9, x minus 2. And when we set each factor to 0, using the zero product property, we'll get the potential solutions of 2 and 9. Now we do have to check to make sure these solutions work, because our initial problem had a square root in it, so we do have to make sure that that works. Let's check x equals 9. What I'm going to do is plug in 9. So when we do that, we'll have 9 plus 7, which is 16. And I want to see if the square root of 16, I want to plug in 9, equals 9 minus 5. So the square root of 16, and there's no negative out in front, it's the positive version of the square root. So does 4 equal 9 minus 5? Yes, 4 equals 4. That means that x equals 9 is a viable solution. The next one that we want to check is we want to check x equals 2, the other potential solution. So what we'll do is we'll plug in 2 just like we plugged in 9. All right, so let's plug in 2. So we'll have the square root of 2 plus 7, and we want to see if that equals 2 minus 5. The square root of 9 is 3, and 3 does not equal negative 3. Therefore, 2 is not a viable solution. So our only solution is x equals 9, since 2 does not check out.